Ever wondered how your phone or smart speaker really understands you? It's not magic, it's automatic speech recognition, ASR, the technology that converts spoken language into text. But here's the catch. ASR systems are only as effective as the data they're trained on. And that data, it's typically labeled. Think hours of real human speech paired with exact transcripts. The problem? Such data is scarce, especially for underrepresented languages or noisy environments. Today, we're diving into a groundbreaking development, a self-refining ASR framework that drastically reduces reliance on labeled data. Instead of waiting for perfect transcripts, researchers are using text-to-speech, TTS, systems to generate synthetic speech, which is then fed back into the ASR model. It's like a student using a textbook to take a test, then studying their own answers to improve. Let's unpack how this works. So how does this system function? Imagine starting with a basic ASR model. Let's say it's struggling with Mandarin. The first step is pseudo-labeling. The model generates its best guess for the text of unlabeled audio. These aren't perfect, but they're a starting point. Think of them as a child trying to decipher a scribbled note. Here's the innovation. A TTS system takes those pseudo-labels and converts them into synthetic speech. It's the model writing a story, then reading it aloud. But there's a twist. This synthetic speech-text pair is fed back into the original ASR model. It creates a closed-loop feedback system. The ASR improves by learning from its own mistakes, while the TTS refines its ability to mimic natural speech. It's a symbiotic cycle where both systems evolve together. Why does this matter? Traditional ASR training requires thousands of hours of labeled data, which is costly and time-intensive. This framework uses unlabeled speech and text instead. For example, researchers tested it on Taiwanese Mandarin, using just 6,000 hours of unlabeled audio and a limited text dataset. The result? A model called Twister that reduces error rates by 20% for Mandarin and 50% for Mandarin-English code switching, where speakers blend languages mid-conversation. And here's the kicker. By leveraging TTS, the system cuts the need for real speech data by 10x compared to older methods. Plus, it scales easily by adding more text to generate even more synthetic data. It's like a recipe that gets better with every tweak. But what about complex scenarios like code switching? In many Asian languages, speakers often mix dialects or languages within a single sentence. Traditional ASR models flounder here, but Twister's synthetic data helps it learn these patterns. It's like giving the model a library of real-world language hybrids to study. This isn't just a technical win. It's a game-changer for low-resource languages and niche domains where labeled data is scarce. By using TTS, researchers are making ASR more accessible, accurate, and adaptable. Whether you're speaking a minority language, mixing dialects, or simply want your voice assistant to understand you better, this could redefine the future of speech technology. So next time you talk to a smart speaker, remember, it's not just about the model. It's about the clever, self-improving systems behind the scenes that make it all possible. Thanks for watching. Hit subscribe for more deep dives into the science shaping our world.